put a bunch of effort into this for this to be effective. Okay, so unfortunately, there aren't too many checks or balances of keeping this efficient, or maybe what's the word I'm trying to look for, to keep this useful. Like if you're like, well, I can get over big time on this. Yeah, you can. But let's try to make it useful.
Oh, it was the CMAS.
All right. So there, the state of Colorado only puts out 2 practice tests for CMAS, and they're both very small. I mean, like there's 4 questions. We'll go over hand sanitizer. 4 questions we'll go over today, and then tomorrow there's like 6 questions on the calculator portion. So I have to supplement. So I will supplement with reviews over everything we've done this year. We'll do quarter 1 today. We'll do quarter 2 tomorrow, and then on Friday we'll do quarter 3, and then Monday you come and you take the test. The test that you're going to take, obviously, the review packet that I'm about to give you is nothing like the test in the sense of how they ask the questions. Most of the questions they ask were to be a bit more. You guys going to pay attention? Most of the questions that I ask are just straight up, hey, just the calculations. All we have to do is put some words around it to make it somewhat slightly more challenging. The calculations stay the same. I'm going to focus on the calculations, but I will show you what the test. So for what it's worth, we'll go over 4 quick questions and then I'll hand out a packet. All right, this is the 8th grade test, what it kind of looks like. Now, yours is going to be paper-based. This is obviously on a calculator. I'm sorry, calculator, on a computer. There are 2 parts to the test. All right, actually, there's 3 parts to the test. There is one section. Hey, I'm not going to beg for you to pay attention. You're just going to be in trouble. You either pay attention or you're in trouble. There's 3 tests and they're broken. I don't know the times for them, but they're, some are roughly about an hour each. You're going to take 3 of them for math. 1 non-calculator and 2 calculator-based ones. The calculator-based ones, you're going to have in front of you a scientific calculator. Tomorrow, I will bring in the scientific calculator so we can all put our hands on them. They will, you've been using this one for a while, probably most of you. It's not going to be this one, but it's going to be one that's similar to this. We just got to find a couple of the keys. Like, well, yeah, but I know where the NPR button is now, or the NCR button. Well, you'll be okay. The other calculator has it as well too, but I'd be surprised if they ask you one of those questions. It is a calculator. Remember, you got to be careful with calculators. I'll do the calculations twice if you're given a calculator. The test also has some unique features in the sense of sometimes there's more than one right answer. So even though much of it will appear to be multiple choice, hey, which one is right? You got to read it carefully. Sometimes it will literally say, choose all the correct answers, plural, right? Let me make this bigger so we can all see this. This one starts off, like I said, they only give me about 6 questions here. The first one is ridiculously easy. Can you see it? What does it say?
Which decimal is equivalent to 1 over 5?
11. 11 over 15. So guess what they want you to do? This is on the non-calculator section right here. So they want you to basically do some long division. Okay. Look at all the answers and what do you notice?
They're all the same.
They all got the first digit is a 7. The second digit is a 3. And if it has a third digit, it's also a 3. So this isn't one of those nice ones where the first digit is all different. So all you got to do is long division to one digit and you're done. This one's going to require to see whether it's repeating or not repeating. Okay. Quick note on repeating decimals. The correct way to write a repeating decimal is whatever is repeated is what the line goes over. What is A telling you that repeats?
7 and 3.
So how would I write that as a decimal? 733, 733, 733. This one says it's not repeating, so it's terminating. This one says what's repeating?
3.
So 0.7. And then the last one, terminating. So we just got to figure out whether this is terminating or not terminating. Yeah.
The answer says equivalent, so the answer is B.
How do you know?
Because equivalent does not mean the exact answer. So
Oh, no, it means exact.
no,
It means exact in math. Your equivalent, it's equal, it's quality. It's not sort of approximately. If it's approximately, it'll use the word approximately. Okay. So this one's just long division. No, I'm not going to do this one. I'm just showing you the question. Do you feel like you could get this one?
Yes.
Right. Certainly, everyone in here should get this one. Obviously, you can make a mistake in the long division, but I'm saying there's nothing challenging about this one. I would expect there's going to be very few questions like this. Most of them will be a bit more challenging than that. Yeah. There's going to be scratch paper. Absolutely. All right. So that one's a pretty easy one. Anybody actually do it?
It's 0.73.
It's B.
B. Yes, it's B.
It's C.
It's B.
How do you know without doing the math?
Because I did the math.
Oh, well, fine. And it's B?
Yes.
So it's a terminating decimal.
Yes. How is it C?
Well, C it says it's repeating threes.
Yeah, but there's no repeating.
Okay, well then I guess we need to figure this out since you guys are arguing. Well, clearly I could grab the calculator, but obviously they want you to do it by hand. 15 doesn't go into 11, so I need to add a 0. 110? I don't know, it's less than 10, so I already know the answer is 7, because all the answers have a 7 in it, right? So I put a 7. 7 times 5 is 35, carry 3. 7 times 1 is 7 plus 3 is 10. I get 15, 150. I already know the answer. Wait, 15? That can't be right.
Math mistake.
It's 5. Okay, so it is very easy to make a mistake. Be careful. 50. 15 goes into 50 3 times. If he's right, it's going to terminate right now.
Yes.
3 times 15.
45.
With a remainder of. Hand me your calculator.
11 to 15.
Hand me your calculator. So, calculators, how many times have I said that calculators are? They're not your friend.
Yes.
If you don't know what's going on with your calculator, what's it say? It says the word FIX. Do you know what's wrong with this calculator? Because a while ago, when I showed you how to say, hey, look, your calculator will round for you, you never changed your calculator back. You've left it in round to 2 digits. And that's why on the bottom here, where it says the word fix. So all the problems you have done between then and now, you have been in the fix mode. So you need to change it from fix to float.
I like it how it is.
Okay, well then you just got to realize, and by the way, you just got this one wrong and everyone else in the class got it right, right? You got to realize that you just gave the easiest question on the test and you got it wrong. All right.
That's sad.
And that is sad because there's not many of the easiest ones like this. There's a couple, we'll see a couple more today. All right. Let's see. So the answer was C, and we're done. Next question. All right. We are going to review this not today, but I believe tomorrow's when we review this. You've done this before. It's been a while. What do you notice?
A fraction.
There's 2 ways of doing this. Hey, we have exponents, and what are we doing? We have exponents, and what are we doing? We have exponents. What are we doing? We're multiplying, right? But we have to remember the rule with multiplying with exponents is you add. So this is, remember, you rewrite the base, and you add the exponents. What are the exponents here?
5.
So it's 5 plus -3, which is 5 plus -3. Therefore, the answer is, well, I got 2 2's here. One's positive, one negative. Which one? It is B. Now, there's another way of doing this. Do you remember where we said that negative exponents actually live? Where do negative exponents actually live? They live on the bottom. So this is really 4 to the 5th over 4 to the 3rd. Do you remember?
So it's
When you have negative exponents, they go to the bottom and you make them positive. So I got 5 4s on the top. I have 3 4s on the bottom. How many left with? 2, and where? Top or bottom? Well, it's still B, right? Either way, you could have done that. All right. There is a third way as well, so you want to hear it?
No.
Yeah.
No.
The division rule says if you have this, what do you do with the exponents? It's division. So what do we do with the exponents? Multiplication says, what do you do with the exponents? Powder of power says to do what? Multiply. What's division say? Subtract. 5 minus 3 is 2. There's a third way. There's 3 ways to get. By the way, this is a very easy one as well too. It's also, we haven't done much of this. When you get to algebra 1, we do this every day practically, right? But in 8th grade, you see it for one chapter and for one section of one chapter, and then we move on to different stuff. So it's very easy to forget. The kids that are on it, sometimes it sticks, sometimes it doesn't. But for most 8th grade students, they have to be constantly reminded, hey, the rule for multiplication, add. The rule for power to power, multiply. The rule for division, subtract. Like I said, by the time you get to high school, we use the rules constantly, so you remember of them, but you usually 8th grade, it's hard. So I would say this is, most kids in 8th grade miss this because they can't remember what the rules were. Okay. All right, and this is also on the non-calculator, not the calculator portion. All right, so that one wasn't too bad. B. There's only 4 of them. Okay, so you're not going to see this one. We did this a while ago. The key here is the word function. Okay? The word function means this. It means it's a mathematical relation where every member of the domain, the input, only goes to one number on the output. I think you remember this as by doing the vertical line test. When you did the vertical line test, when the vertical line went across the shape, if it ever touched in 2 spots, it was not a function. We think about this as in the XY coordinates. Hey, this would be 2 points that have exactly the same Y values. Those are not functions. Whenever you see an input-output and it says, which is not true, it's wherever. You guys all came up with this yourself. We did this a long time ago. This is the one that said no repeats in the domain. So we are allowed no repeats in the inputs, no repeats whatsoever in the inputs. So when you get a problem like this on a CMAS test, you are looking for repeated X values. Okay. Okay. So they love these questions on CMAS. You're going to see probably 2 of them. So all you have to do to figure out which one is not true, notice what the question says. Doesn't say, what's the next number? It kind of looks like it should be. It says, what could not go here? Which of the set of, oh no, it's the opposite of that, sorry. Which set of values could be included? They can ask it one of 2 ways, which could or which could not. The ones that could not would be repeated X values. That's the input. The ones that could be are the ones that don't repeat. What are my X values right now to start with? That's it, right, in question mark. So 2, 3, and 4.5. So we are simply, because it's which could, any number that's not that. So let's look at our possible answers. Which one is not a, what did we say, 2, 3, or 4.5? Which one is not a 2, a 3, or 4.5? This one could be. That one has a 2, so it's not that. That one is a 3. Could be this one. Well, and that's basically what we're doing. We're just finding ones that are not 2, 3, or 4.5. I don't know. Let's look at it. It's hard to do on the screen here. Negative 4.5. So they're trying to trick you up here, right? Because in mind, you're thinking, okay, it can't be a 2, 3, 4.5. You see a 4.5, you don't notice it has a negative. So that one is good to go. All right. Once again, we do that one time in 8th grade on one chapter, one section. We forget about it, and then all of a sudden they throw it in our face come CMAS time. All right. I think we got, what, 2 more left? 1 more left. We'll do the, oh, you better get this one. Okay. We literally just did this one. Grayson, you remember doing square roots? You just took the test. Hey, what's the square root of 25, Grayson?
5.
All right. What's the square root of 24?
4.9.
Gosh. Why is it? Well, you're just going to agree with him?
Yep.
Why? How do we figure out the square roots of non-perfect squares like the square root of 10? Who can talk me through the whole procedure? All right, Abby, go.
So you can figure it out by like having like seeing where the numbers are closest to
Okay, what will those numbers be?
4 and 5.
No, not 4 and 5.
Oh,
No, we're doing that. Don't look at the answer. Just focus on, you just did this last chapter, by the way. And what you said was right. We're trying to figure out what two numbers squeezed in that are perfect squares.
So that'd be 3 and 4.
She's thinking one step ahead. Instead of saying 3 and 4, she should probably say, I mean, I know what she's thinking. She's thinking the square root of 9, the square root of 16. So we're going to put a 9 and a 16 and take the square root of both. Square root of 9 is,
3.
square root of 16 is. She said 3 and 4, I'm with her, right? Okay. Is 10 closer to 9 or is it closer to 16?
16.
You said 16.
I'm at 9.
I meant 9. Okay. So if 3.5 is dead smack in the middle, are you closer to the 9 or closer to the 16? I'm closer to the 9, right? Because 10 is only 1 away from 9, right? I'm not closer to 16. Okay. So what's your guess? She's guessing 3.1. What's your guess? 3.1. Anybody guess 3.2? All right. Turns out I don't know what the answer is. It's 3.1 or 3.2 or somewhere in between. Well, let's look at our possible answers here. Okay. It's weird because there's circles here, but how many circles or tick marks are between 3 and 4?
4.
So what are they going by?
2.
So the first one is,
Correct.
second one is 3 point. What do we say our guess was?
3.2.
3.1 or 3.2. So what's our only possible guess here?
The first one.
And you're done. There you go. Good job. Questions? All right. Unfortunately for us, that's all Colorado gives us. Those 4 questions. Or they gives us 6 on the calculator. We'll do a calculator test tomorrow. I'll pull out the calculators that we're actually going to use on the test. For the remainder of the class, lucky you get a. No, it's a guided worksheet. All right. So this is everything, believe it or not, that we've learned in quarter 1. This is everything that we've done in quarter 1. Lots. All right. Now, let's talk about how we're going to do this. Quiet, please. Let's talk about how we're going to do this. Step number 1 is we're going to do this together. We're not going to do this individually. We're not going to sit there, mess around, talk. We're going to do this together. I'm going to do 1 to 2 questions on every section with you. And yeah, I'll be calling out people, hey, describe what's going on here. We'll do 1 to 2 sections. We should, in the remaining time, get through, I don't know, 20 to 40% of the whole packet. There are 75 questions. There's 75 things here, right? Most of them are pretty quickly done. Remember, these are just the calculation portions of it. Our goal is to get through as much of this in class as we can, and the remainder is homework, okay? So let's be efficient. Pass up. There's some one, please. Let's I'll collect homework here at the end of class. Let's get through as much of this as we can. So here's what I need.
There's something on my desk.
Leave it.
I work from here.
All right, let me pull this up and we'll get going. Need that. I need this. All right. So yes, there are 75 questions. It seems like a lot, but trust me when I say it's not too bad. Donovan, are you online right now? Nope. Okay. Yeah. It's still good practice. Remember, we'll be taking our semester final here in a little bit. Okay. Eyeballs up here. Let's do this. First 6 questions are over what?
PEMDAS.
PEMDAS or GEMDAS in 8th grade and higher. So GEMDAS. Jenna, the G stands for? Because you get a question every day, multiple times, so does everyone in the class.
No.
G stands for? G stands for grouping symbols. In 7th grade, it wasn't a G, it was a P for parentheses. However, by the time we get to 8th grade, we have more than just parentheses. We have absolute value. We have square root. We have cube root. We have fraction bars. They all act as grouping symbols. They basically say you have to do that part first. The G stands for grouping symbols. Okay? Christian, the E stands for exponents. The M and the D stand for somebody?
Multiplication, division.
In what order?
Multiplication and then division.
100% wrong. 100% wrong.
How? It goes.
Doesn't matter.
Oh.
What's the order?
Oh,
Whichever comes first, which way do you mean?
like in the like if it's like
From
left, right.
left to right. So we have to go left. If you do the multiplication before you do the division, you're going to get it wrong if they flip the order around. They can. Division is not commutative. You can't do it in any order. We have to go from left to right. The same thing with addition, subtraction. We have to go left to right. Get rid of all your multiplication and division, not the multiplication first and then division. Get rid of all multiplication and division from left to right. All right, well, this one's pretty simple. There's nothing but addition here. So let's not look at number 1. Let's look at number
3.
Let's look at number 3. We can look, I said we'd look at 2 in each section. So number 3, got a bunch of things going on there. David, what are we doing first? By GEMDAS. What grouping symbols do we have there? We have parentheses, 4 minus 2, which at least in my world is, which is 2. Don't forget there's still an exponent there. Hey, we got an E for exponents. 2 squared is
4.
So this is 16 divided by 4, which is, that wasn't too bad.
Now let's do 4.
I've absolutely in 8th grade, not that I've ever looked at the test because I don't, but I absolutely positively know that they have PEMDAS, GEMDAS stuff on CMAS test. Usually it's like what Jane was saying. It will say which expression is equivalent. They're basically asking you to do some GEMDAS. Number 4 looks pretty easy. How about number
6?
All right, let's do number 6. Boy, look at that. 2 plus 2 is 4, yes? It's just sitting right there. Don't you want to do 2 plus 2?
No.
Sitting right there. Somebody will get suckered into doing that. Like, well, 2 plus 2 is 4. I know that. You have to get rid of all multiplication division first before you do any addition subtraction. So if we go left to right, since there's only multiplication, this one you could do in any order. But as soon as they throw some division, you have to go left to right. 4 times 2 is 8. 2 times 6 is 12. So we get. That's why there's 75 questions, because many of them are done very quickly. Very quickly. All right. Next section is what? Verbal expression. They're going to give you, this is kind of more practice than it is like, I don't think they literally will give you something like this, but it's a word problem. You're going to have to read a verbal expression and turn it back into this. So that's why I'm throwing this in here. Hey, what was a $20 word for subtraction? $20 word for subtraction. It's not minus.
Subtracted.
Difference. So how will we write this using the word difference?
What is the difference of 21
What is the difference of 21 and 19? But guess what they almost always use when they have subtraction? They don't use the word difference.
less than?
They use a less than or fewer than. So how would you write that with a less than or fewer than? Go.
19 less than 21.
It's always the opposite of what you think. It's not 21 less than 19. It's 19 fewer or less than 21. It's the subtraction is the one that causes everyone problems. Be careful. Read it carefully. If they do give you that $20 word, life is good because it's written in exactly the order. Remember, division is the same way. $20 word for division. $20 word for division.
Quotient.
This is what we don't finish in class. Okay. Quotient is the $20 word. What's $20 word for multiplication?
That's
Not for multiplication.
Division.
product.
Product. And then for addition, the $20 word is sum. Okay. All right, so those are pretty easy. What about squared? That's the only word, squared. All right. They could say to the second power, but it's going to be squared. Or they might say the number times itself, something like that. They say the number times itself, that's pretty self-obvious though. All right, moving on. Here we go. Simplify, big fancy words for do the math. Back again to multiplication rules. When you multiply with exponents, what do? When you multiply with exponents, what do? The only rule you have to make sure of is the bases have to be the same. You can't multiply k with an a or a k with an x. You can multiply k with another k. Can you multiply 3 times 7? Heck yeah, that's k to the 6th power. Everybody see that? Remember, the other one had a negative involved. Okay. We still added though. We did, instead of doing 4 plus 2, we did 4 plus negative 2. Okay. But the rules still stay the same. Okay. Pick one that looks hard there in that section.
21.
In that section.
No. Wait, can we do like the ones on the back?
15. Take a look at 15. Okay, there's 3 things. Big whoop. It's still 3 things. 5 times 5 times 6. 6 quarters is $1.50, right? So 150. K. Oh boy. All right. All right. I'm not touching that one. What do we do with the exponents? Add them. Why did I put a 1 there? Because if there's no exponent, there's always a 1. So add. You get to the 5th power. You're done. Now, probably on a CMAS test, one of those would be a negative, both in the coefficient, the number out front, or one of the exponents. The rules don't change. You multiply the coefficients, you add the exponents. Lastly, just remember, I didn't give you any, but you can't multiply uncommon bases. All you can do is squeeze them together, okay, for multiplication. So if they gave you a k and a t, then you can't multiply k's with t's. Yeah.
Can we do like 20 or 60?
When we get to that section, sure. We're not there yet.
It's still like the same sentence.
All right. The next one is a different rule. What's the rule? What's the rule? What do you got?
I don't remember, both things get.
We have a power raised to another power. This is power of a power. What's the rule? It's not add. It's not subtract. It's multiply. Power to a power, we multiply, but here's the kicker. You got to multiply all the exponents. This 2 on the outside goes to every exponent. What do I mean every? 7 has an exponent. What's this exponent right now?
1.
So 2 times 1 is, so I get 7 to the 2nd power. I get v to the,
6.
what's the rule?
8.
You multiply. They will most likely not write this as the answer. Guess what they'll write as the answer?
49.
They'll write 49 instead of 7 squared. It could be either or, but most likely they will put 49 instead of 7 squared. There's number 16. All right. Which one did you say you wanted to do?
Number 21.
Is it a power to a power?
No.
Well, then we're not there yet. Pick a power to a power.
18. 20.
They're both the same. 18 is a bigger number, but all right, let's do 18. 6 is to what power? So 1 times 3? It's 6 to the 3rd power, and to the,
4.
I heard 4. Where did we get a 4 from?
Before you.
Okay, before you multiply, it's 4. When you multiply, you get a 12. The book probably won't put 6 to the 3rd. They'll do 6 times 6 times 6. The only time they probably won't is if it's like, I don't know, 4,000 to the 3rd power. And maybe they won't do that. All right, 6 times 6 is 36. 36 times 6 is 216. Is that right? 216. All right. Last rule is the division rule. And we've already said what the rule is. What's the rule for division?
You
Subtract. Now, I showed you two ways of doing this. One using the subtraction rule, one using the canceling rule. I'm going to show you both again. I'm going to show you both again. You ready? Most people like the canceling rule. Here's the canceling rule. You treat the numbers with the numbers. 8 over 6 reduces to how many x's on the top?
2.
How many x's on the bottom? So if I wrote 2 x's on the top, 1 x on the bottom, and I canceled, I'd be left with
1 x on the top.
and you're done. Okay, what's the subtraction rule? The subtraction rule says, well, 8 over 6 is still 4/3, but that would be 8 squared minus 1. 2 minus 1 is 1. So positives go on top, negatives go on the bottom. Well, it's positive, so it goes on the top. Most people like canceling because I don't literally need to draw that out. I just need to think about it. 2 x's on the top, 1 on the bottom. When you cancel, you'd be left with 1 on the top. By the way, you're doing subtraction when you're thinking about that. All right. What was the hard one? What is it? 21 or 22?
21.
21. All right. Well, can you reduce 8 over 7? How many on the top?
3.
How many x's on the top? How many x's on the bottom? So what are you left with? On the, because remember, it could be reversed. If there was a 2 on the top and 4 on the bottom, then what would you be left with? You'd be left with a negative where the negatives live on the bottom, right? Or you can simply say, if there's 2 x's on the top and there's 4 on the bottom, when you cancel, you'd be left with. Most kids think about this as canceling rather than subtraction. Either way is fine. I find more kids are more like, you can wrap their head around this a bit easier.
Really?
The issue is like when the exponents are really weird, like, I don't know, 73 and 41. Okay, then maybe I need to use subtraction because I can't think and cancel those big numbers in my head. Okay. All right. We good on that section?
Kinda.
All right. Next section starts on what? What number? 24. Let's take a look at 24. What are we doing? We are rounding. All right. My 7th grader, Miss Garland, was there for that. It was horrible. I'm asking my 7th graders who remembers how to round, and it was like pulling teeth, right? It was horrible. Can you do it, Christian, without making a mistake? Oh. All right. Round. Tell me the rules. What do we do? Number 24. Thank God. You look to the right. I don't look at the number that's underlined. By the way, this worksheet underlines, and most of the time it'll say round to the nearest 10th. So you underline the number in the 10th place. You look to the right. Keep talking. The number to the right. 5 or bigger. Then we round up one that's underlined up by 1. Well, it's not, so we leave everything the same, and what do we erase? The 4 and the 8. The things that from the whatever's underlined, we keep that, and we get rid of the rest. Yeah, you're doing this? All right, so what's the answer here? 5.5. I gave a big long speech to my 7th graders. I was like, do not get to 8th grade and not know how to round.
I do round.
Right? Do not get to 8th grade and not know how to round. You got to ask for help. Come to tutoring, something. We don't teach rounding. We do rounding in 8th grade. All right, that's rounding. What's the next section? All right, what are we actually doing here? Yeah, but what are we actually doing here? We're dealing with integers, positive, negative. All right, really quickly. You guys are pros at this. You should be able to do this. What is the rule for add, subtract, for positive and negatives? What's the rule? If the signs are the same, what do? You add. If the signs are different, we. Now remember, I'm going to skip the part where we say big minus small, more negatives, more positives. Okay, what's the rule for multiply, divide?
Negative.
Negative, make a positive.
So I still use those same words. Same means same means positive, different means. Now we extended this slightly further in 8th grade because remember, 7th grade, they only give you 2 numbers. 8th grade, they may give you 10 numbers. If you have an even number of negatives, we're talking multiplying and dividing. If you have an even number, the answer is always
Yes.
If you have an even number of negatives, the answer is always
Yeah, positive.
a negative times a negative is a.
Positive.
So if I had an even number, 6 of them, I get a positive.
Yeah,
If I have an odd, well, these 2 multiplied together is positive, and they got that 1 negative. So you could, for 8th grade and higher, you could also, instead of writing the word same, you could write even number of negatives or positives. You got to be careful because it doesn't matter whether the positives are all even or odd. We're talking about negatives. And if you have an odd number of negatives, the answer is always negative. So those are kind of like the modified 8th grade rules. If you got nothing but positives, the answer is always positive for multiplying and dividing, not for adding and subtracting. All right. So we just have a bunch of problems here that run through, just some practice here. Hey, same and different signs. So where you are, add those 2 numbers, the answer is
Negative 12.
this is why I like teaching 8th grade and higher, because you guys know the rules, right? 7th grade is when I teach the rules, and it's painful. By the time we get past Christmas, all 8th graders know these rules. All right. I just want to point out, I don't have one. Let me point this one out. Jenna, give me a number. Positive or negative, doesn't matter. Speak, give me a number. 2 minus negative 3. With 2 negatives, either with or without parentheses, doesn't matter if the parentheses are there or not, but 2 numbers are next to each other and you have 2 negative signs, what happens? All right, is anyone lost on that? Like I said, this is why I like 8th grade. All right, good. Okay, I'm not going to go over any of those because those are just quick practice problems. So we will go to section number. Here we go. Okay. Notice, not like things, different variables. Some of them are positive, some of them are negative. Guess what they want you to do? They want you to swap positions. If it's negative, it's on the bottom, it goes to the top. If it's negative, it's on the top, it goes to the bottom and becomes positive. So all they're asking you to do right here is basically reduce the fraction. You're like, what fraction? It's going to be a fraction because we have some negative exponents. So the rule is, if it's a positive exponent, it stays on the top. So you put an equal sign in a fraction bar. If the exponent is positive, it stays on the top. If the exponent is negative, it goes on the bottom, becomes positive. Okay? Not the value of the number. Negatives still stay negatives. We're talking about the exponents that you change. All right. Is the exponent on 6 positive or negative? Look at 6. Is the exponent positive or negative?
Negative.
The exponent on 6 is negative.
How positive?
What is the exponent on 6?
1.
It's 1. 1 is positive. So where does it live? It lives on the top. Done with 6. What's the next thing? A. Is the exponent positive or negative? So where does it live? And you make it positive. See what it did? Last one, positive or negative?
Positive.
So where does it live? On the top. Okay. Occasionally they may make it harder. They may put this as a fraction. So maybe you have x to the negative 4. Doesn't matter where the negative is. If there's a negative exponent, it flips position. If it originally was on the top, it moves to the bottom. If it originally was on the bottom, it moves to the top. You've got to treat each one individually. Each one individually. Okay, pick a hard one.
Number 67.
In this section.
46.
46. Okay, 46 is usually missed by students. I said the first thing you're going to do on these problems is put a fraction bar. The fraction bar stays there. Negative exponents move positions. Hey, the first one, positive or negative? So where does it go to? Second one, positive or negative. So where does it go to? And if it's a 1, you don't have to rewrite the 1. Okay, anything left? Can you ever have a blank on the top? You know. Okay. Questions? Is that it for that section? Next section, what's the topic? Ooh, who remembers? There will absolutely positively in 8th grade be scientific notation problems. All right, I need to put this in scientific notation. The first thing I always told you to do was look at it. Is it a big or a little number? Little number have what kind of exponents? All right, you remember. Good job.
3 times 10 to the negative.
Well, thank you for allowing us to not get to the answer. But yes,
Is that right?
you were right. Well, I didn't count it, but at least you have the exponent as negative. I just wanted to stress the fact that it's a big number, bigger than 1. It's going to have a positive exponent. If it's a small number, between 0 and 1, it's going to have a negative exponent. We simply need to count, and I remember I always recommend not putting loops. People screw it up. Dots. 1, 2, 3, 4, 5. So I do get, in fact, 3 times 10 to the negative 5th. Done. Okay. All right, that's taking a number in standard form and putting it in scientific notation. Jenna, if you had a pencil in your hand on your paper and you were paying attention, you would look like everyone else in this class. When you're looking at your lap or whatever you're doing, you're not paying attention. Come on, you can do this. Jenna, big or small number? It's big. Big numbers have positive exponents. So the decimal starts right there. We simply count till we get a number between 1 and 10. It can be 1, but it can't be 10. Let's see. 1, 2, 3, 4. I get 2.94. That's it, right? 2.94 times 10. How many spaces did I move it? How many places did I move it? 4. 10 to the 4th. 2.94 times 10 to the 4th. The other way they could ask this question is if they give you scientific notation and ask you to put it in standard form. We spent, I don't know, 2 days on this, if I remember, or 3 days, because the third day we did adding, subtracting, multiplying, dividing. The other way is if they give it to you and they say, write it in standard form. The key here is understanding the difference between a big and a small number. On a big number, the zeros go, big numbers, the zeros go to the right. On a little number, 0 goes to the left. Big or small number. So the zeros go on this side.
You said that backwards.
What did I
You
say?
said small numbers go this way with the zeros.
They do.
No, wait, you said it.
They do. Little numbers, the zeros are on the left. Big numbers, the zeros are on the right. Think about 4 billion. Where are the zeros? They're on the right.
Oh, you're talking about.
You have $4 billion, Jaden. Collect your $4 billion.
I thought you meant like just in general word of the zeros, right? You think you meant.
Okay.
That's like,
Well, come on, collect your $4 billion, Jaden. The zeros are on the left. No, the zeros are on the right for big numbers. So let's see. It's small, so I need to put the zeros on the left. And then I have this number, 2, and then I'm going to move the decimal place. How many places?
4.
Now, did I add 4 zeros or did I add a bunch? Some of you have figured out how many you need to add. Some of you are like, I still don't know what they're doing. Be careful. Don't assume you know it. Just put a bunch of zeros and then move your decimal place. How many times? 4 times. 1, 2, 3, 4. There's where it lines up. Erase all your extra zeros. Make it look nice and pretty, and you're done. Because I don't count zeros. Inevitably, I'll make a silly mistake if I start counting zeros. I put a bunch and just move it. How many decimal places? Okay. For those of you who don't want to do that, you can figure it out. And there is a pattern. Just be careful and make sure you fully. Could you please turn around your desk? Face the board. Fully face the board. Thank you. Now put your mask on. All right. So the only difference between that and this one is the number is positive. So Jaden, where do the zeros go for positive? Thank you. He's pointing to the right. So I put the number in a bunch of zeros. I can erase them. It's no big deal. I'm not going to put 20 zeros, but I'm not going to put 3 zeros. And I'm going to move the decimal place 3 times. 1, 2, 3. Erase all the rest. Get rid of the extra zeros. 8,200. What are you doing? Why are you messing around? Out. Seriously, everyone else is seated in their seats, paying attention. It'd be one thing if you did it one time. All right. So that's that section on scientific notation. Now, they might ask you to do some multiplying. They might ask you to do some dividing. I don't have it on this practice one, but we can multiply pretty easy. 2 times 10 to the third times, give me another number in scientific notation. In scientific notation. 3 times
10 to the 4.
Okay. How would we do that? We got to multiply those two numbers.
Oh wait. Yeah. Would it be like 5 times 10?
Because 2 times 3 is 5.
No.
So it would be
6.
times 10 to the.
7.
Okay, you did it. The only time this becomes slightly weird is if this first number and that second number was 6. Then you would get,
12.
but remember what you did? If this number is big, what do you do to the exponent? Remember, you did this year. No. When this number is bigger than 10, what do?
You added 0?
No. Well, how do you put 12 in scientific notation? 1.2 times 10 to the, how many places did you move it? Times 10 to the 7th. So what's the final answer? So what did you guys figure out was the easy way, because none of you wanted to do this. What did you guys tell me? I'm not doing that. What are you going to do when you get that as an answer? How do you go from here down there? And so what I said, big or small, when that number is big, then this number goes up by however many decimal places you need to move it. You guys don't remember doing this? You did this. Okay. All right. Which is why we're reviewing it. Okay, next section. We're almost out of time. Next section is fractions. We're not going to go over that. I'll just remind you for multiplication and division. Are you allowed to multiply or divide mixed numbers? What do you have to do first? When you convert this to a mixed number, you ignore the fact that it's negative until the very end. You don't do 8 times negative 2 and then add 3. 8 times 2 plus 3 over 8. All right. You have your homework in front of you. See you tomorrow.
Yeah, what about our homework? Sorry, he was looking at my
I don't care when you disturb my class like that. All right. On Christian's desk is the basket. Please place your homework in there and then cards.
Jackson.
I have no idea why I messed up both the names.
Where they're wearing the same outfit.
Yeah, but they don't even look alike.
I know.
They're both tall.
They are tall, that's true.
Wow.